Everybody. Um, so we're going to do it a little different from the previous panel. Each of us have a bunch of slides to show first, and then we'll get into the discussion, the fireside chat. Okay? So first of all, briefly introduce my colleagues here. Since I've already been introduced, so let me start off introducing in the order in which they're sitting there. Dr. Suraj Rangarajan is the Managing Director and CTO of Applied Materials India. Okay, so he's going to speak on this matter both from business aspects as well as equipment suppliers' point of view in the display industry. Before he does that, I will speak on the industry jargon. What are we talking about in terms of display? Is it semiconductor-like or is it non-semiconductor-like or a combination of both? Just to get the basis set. After that, it'll be, after Suraj, it'll be Mr. YJ Chen. He's CEO of Vedanta Displays, and he comes with very rich experience in building fabs. Over the last 6 years, he's built handful of Generation 8 fabs in China. So we have a very experienced group here. And next to him sitting there is his interpreter, just in case he doesn't understand my English or his English, okay? But I think he understands fully, but just in case. Okay. And then we have Dr. Ajit Aras. Ajit is from Sharp, Singapore, where he's the Executive VP of Sharp Singapore Electronics Company. And he leads the device business. So we have people covering all the various value chain components. So we won't be all purely technology focused. We're trying to figure out how to create a display industry in India. And I've been at it here in India for the last 4 or 5 years, getting the background set with the help of many of you who have the same interest. And display technologies fall under the India Semiconductor Mission. And so we start with, I'm being helped in the distant, over there in the back by Dr. Kundu from ISM, and he'll be changing the slides for the rest of you. When you want slides change, you wave at Dr. Sudarshan Kundu. So let's get started. We have about 45 minutes, I believe. So we're going to go around in a circle with our slides to show our perspective and our experiences, and then we'll come back to talk about how do you create the dynamics of display manufacturing and the infrastructure in India. Okay. Besides this role, I'm also a professor at IIT Madras. So I hope some of our young people here, we need all of them to get into this kind of business, learn manufacturing, learn technologies, and contribute to the growth of this in India. Because in India, the market has grown substantially. There's a lot of consumers, and the market looks big, and every one of those displays and those display-centric gadgets have to be imported into India right now. So with that, let's start discussing this. Dr. Kundu, can we put my slides up? If he's waving at me, I can't see him, he's too far back. Okay, there it goes. So I already introduced the panelists. So I want to take you through some context setting discussions. So there are 5 visuals or slides. So first one is the growth of the display manufacturing industry. I've been at this for last 30 years, okay? I also do on parallel solar. So I've spent 60 years on these things in the same time frame of solar and displays. But here is a history of how the industry came to be. After the demise of the CRT tubes, and that happened in the, around 2000, it has been the plain sailing and the growth of flat panel displays. So flat panel displays are now called the display as we speak. Each time it grows, and the y-axis scale in this reaches about, it's in billions of dollars. It's about $150 billion in 2020, and that is that's a year of the pandemic and so on, but it still kept growing. Each time the market has grown, it has been driven by some particular killer application. So the birth of the flat panel occurred when IBM and Toshiba brought out the laptop computers, the notebook PC, NBPC, and after that, first generation of growth and fabs in Japan, they went into monitors, and then fabs started in Korea and Taiwan, and the TV grew. Because the products became larger and larger, and I'll explain to you the economies of scale in display manufacturing, that TV drove the growth of big fabs. The fabs that are so large that it takes 4 kilometers to walk around some of the modern fabs. Okay? So the TV size drove the size. Now what happened at the end of this TV growth period around the mid-2010, 10 years ago, there's been a different growth of small, high-volume products, smartphones. So I want to leave you with the question, and also for the panelists. Okay, notebook PC, monitors, and TV, then, over the last 20 years, has brought it to a $150 billion business. Mobile phones are now reigning supreme. But it wasn't a long time ago, it was only 10 years ago, 2011, that mass production of smartphones began. Okay? So that was 10 years ago. So every 10 years you can see there's a new driver for displays. The Society for Information Display, which kind of coordinates all the display supply chain providers, the display fabs. You'll be hearing from Dr. Achin Baumik, who's the president of SID. I didn't introduce him because he'll do that before his pre-recorded video. So something else is there, and maybe there'll be all of these in much larger numbers, but they're thinking it'll grow double the size in the next 5 to 6 years. I don't see how it is, but maybe one of our business colleagues here can project some potential growth opportunities. So next slide, please. Okay. Now, when you talk to semiconductors, you're talking about the little circle on the left-hand side, the 300 millimeter wafer, where the economies of scale is in smaller and smaller feature sizes. For us, it has always been growth of the substrates. So the generation 2 substrate, which is about the 300 millimeter wafer size, happened 1980s. Okay, the Sharp was one of the key founding pioneers in technology, so was Applied Materials, in creating the display industry at that time. Now from Gen 2 to Gen 10.5, a whole variety of fabs have been built. In operation today, maybe there are about 60, 65 fabs in the world. And Mr. Y.J. Chen has built the last 4 in HKC while he was at HKC. So I hope you'll do a lot more things in India. 10 fabs, maybe more fabs. So this technology and this business industry requires a lot of know-how. You know, it's not just getting the technology driven and demonstrated. It is putting it all together, all the things I'm going to show you. So the industry jargon, you have to always think about what product size drives your fab investments. And you can see on the picture on the right-hand side, from IT products to TV products, the size went up. So fab size went up too, because there is something called N-ups. How many pieces of a product can you fit on a glass? And typically this has to be at least 6 or 8, depending on the type of product and the market prices it can bear. So the N-ups, I called it here, is a made-up word in display industry. You need to have more than one. If you can make TVs the old-fashioned way, you make one TV at a time. That's my goal, eventually, of getting into micro factories, and that's the kind of research I'm working on in IIT Madras with my researchers and students. And there's a poster on that somewhere in the next hall. So the product size went up, the fab sizes went up, but now this generation of products are much smaller. You can make 500 and 700 pieces of displays on a single substrate. So now what is the economies of scale? Do you build a big factory or a small factory? It all depends on the technology you select and what aspects of it. So please remember product size, N-ups, and mother glass, MG. Mother glass is the size of the big glass on which many products are situated. And the capacity of a fab is measured in number of sheets of the mother glass per month. So there are more jargon, but right now let's stay with this. Next slide, please. I should say that LCD fabs, liquid crystal display fabs, require larger fabs because they are typically oriented towards larger size products. AMOLD fab are limited today because of this limitation on technology of scaling and patterning. Okay, next slide. So a very brief look at what are these devices. On the left-hand side, on the top left-hand side, you see a cross-section of a liquid crystal device. On the bottom, the highlighted in blue is a TFT substrate. TFT substrate is typically called the backplane in this technology. And above that is the liquid crystal fill, the color filter, and the light comes out, and the light is coming from the backlight assembly. So it's an assembly of several subsystems of technology. If you go to the market and say, I want to buy an LED TV, which many people do by mistake, there is no LED TV available for consumers. It's all LCD or OLED. The reason it's called LED TV is because the backlight went from cold cathode, the CCFL backlight to, which I believe Mr. Y.J. Cheng has been, used to make CCFLs a while ago, right? So that's all LED. So marketing people just call it LED TV, but there's only two major classes of technology today that cover most of the $150 billion of revenue. So the TFT backplane and the liquid crystal, the front plane, are manufactured at size, at scale, at the sheet size. The same with OLEDs as well. It has a backplane. By the way, this technology was developed by me 22 years ago, and has gone from a laboratory where I took it from to manufacturing to a $50 billion industry today. So next growth in the smartphone segment, because of flexibility, we think there's going to be a lot of growth in that area. Whereas the TV and notebooks are still in the LCDs, and they are the big brother in the two technologies. So one is called AMOLD, which is active matrix OLED, and liquid crystal display is the LCD display, even if the backlight is made of LED. Next slide, please. I won't go through all this, but I want to make a point here that we are in a semiconductor conference, and many of you are experts at this, but very few of you have actual experience, I think, in flat panel displays. So I just want to say that the backplane technology, TFT manufacturing, is very much like a semiconductor manufacturing. It uses similar processes and similar items, but Suraj will comment on applied materials, capability in making very large machines to accommodate all these big size. So it's only a question of size of the substrate, but the other processes are more like semiconductor in the first left-hand side block. But then you need a lot more technologies in the front plane, depending on which technology you select, liquid crystal or OLED. And module technology is more discrete. They're done at the panel size after cutting the glass into panels. And one of our speakers from Sharp will speak on that aspect of it. So remember this, there is a lot of technologies here, but this one requires semiconductor technology plus more other analog technologies, because what you see is analog. The eye absorbs and integrates the image. Next slide, please. One example I've shown you is the typical semiconductor process is depositing thin films on a substrate, patterning them, etching, and getting ready for the next level or mask level. It's very similar here, except we do it at a large scale, MG or mother glass in, and eventually after multiple levels of masking, you get the TFT out, ready to put the front plane on it. And that's how semiconductors are made. The number of mask steps will depend on which technology you select. So TFT backplane process and flow are similar to those used in semiconductor fabs. Next. Next slide, please. So a display fab, about which we're going to talk about, the dynamics of manufacturing depend on many factors. Market pull, equipment, materials, know-how of putting it all together, people who have to run these operations and have the skills, not just the people, also the management of these fabs. All of these come together as an ecosystem that needs to be built in India, and all the leading companies in the world are willing to come here and do it because they see a market potential. We just need to encourage them. The ISM has done a very good job of defining what needs to be done. We need one LCD fab and one OLED fab to get started, and then we are on our way. So with that, I'm going to stop, and we'll move on to Suraj. He has some slides to show, and he'll go in that order. and then we'll come back to discuss over there. Move to Suraj's presentation, please. It's coming.
Sure. Thanks, Raj, for that tutorial. I think we should have probably named it the display tutorial session. I think for anybody who did not have an introduction, those 5 slides give a very, very good introduction of what the display industry is all about. And as soon as my slides are loaded, I wanted to just give a sense of what Applied Materials does in this space. Next slide. For those who missed Dr. Prabhu's presentation, this is an overview. We are more than 50-year-old company, founded in 1967, semiconductor company, 26 billion revenue, very large R&D, very large IP, and very global. Next slide. 3 main businesses. Most of our business is semiconductor, and I think Prabhu spoke a lot about this part of the business this morning. There are 2 other businesses. One is the service business, our AGS, which does a lot of the service for factory solutions and all that, and the one that we are going to talk about today, the display market. Next slide. So this is the DFT, the display and flexible technology market for Applied Materials. This portion of the company was founded in 1991. This was a JDA with Komatsu Technologies, and then Applied Materials became a full owner, and this became part of Applied Materials, headquartered in the US. Again, very global, manufacturing in Germany, Taiwan, and Korea. The display part of our business is not as big, about 1.3 billion, and you can see the spread. So, but this is still a significant part of our business, and this rides on top of the semiconductor stuff. As Raj showed, a lot of the steps on the backplane are semiconductor based, so there is good synergy between what we do in the display business and the semiconductor business. Next slide. So click once more. Okay, yeah. So basically, if I think Raj explained this very well, the bottom part of this is the black plane, the TFT, and this is common. Whatever display you do, this backplane is required, and this is what Applied Materials does, and the scaling from the 2-inch to the, to now whatever we have, the garage door size equipment you can see over there. All those were pioneered by Applied Materials over the past few years, and we are the leader in this part. The front plane is something that's where innovation comes in as you do new applications. There is a lot of material innovation, application innovation on the front plane. Keep going, next slide. Now coming to Applied Materials India. So the picture here is from the Applied Materials office in Bangalore in Whitefield. So we now have a total of 6 different locations in India. Bangalore is our headquarters. We also have presence in Chennai, Coimbatore, Delhi, Mumbai, and Pune. And this Applied Materials bug was made using our employees. This was a few years back. Next and last slide. So based on all this, we hope to make possible a better future, and we will be talking a lot more about Applied Materials solutions and the different scenarios and applications in our fireside chat. Thank you.
Mr. Chen, next.
Hello, everyone.
Finish all the presentations first, then you can give us a rousing applause after that, okay?
Yeah, please, go ahead. Okay.
Hello, everyone. I'm YJ. I'm from Taiwan. Yeah. I'm working in Redenta display now. Okay, let me brief introduce Redenta. Next one. Thank you. Redenta did invest across diverse session over 30 million and contribute to India GDP around 1.4%. And annual revenue is around 20 billion. And we had experience of a global footprint over 15 countries. And the employee of Redenta Group are over 100,000. Next one. And for Redenta display project, I think we got 4 points, and we got a very confidence we can build a very good fab in India. First of all, is we got a support of InnoLast with our total technology support, and including product and the fab design. And the second is the site support of dholera, Gujarat. And third is until now we did a signed MOU with over 17 customers. And for the LCD industry, everybody know there are a lot of bone material. And we now 100% we sign all for the supplier will join us if we kick off the project. And the other around 11 SEM partners, yeah, including big parts of polarizer, driver IC, flexible print circuit. So, and they are glad to invest and join us for our display project. And by the way, Alphonse Strait is a glass maker, one of the 4 in LCD industry to provide a glass substrate. And it belongs to Redenta Group too. Yeah, so yeah, we will get a very good support from our group-owned company. And the next one is I will help to include many specialists to join us to develop the LCD industry in India. Okay, next one. Next one, please.
Next slide.
For my own personal profiles, I was graduated in the graduate school of Tsinghua University in Taiwan and majored in material engineering and science. After military service in Taiwan, that's 2 years, I started to work in Chime. That's maybe second largest of LCD maker in Taiwan. Yeah, that's from 2000 to 2006. Yeah, then I used to be the consultant of coating glass, and from 2007, I worked in the Chime Group as a fab director for CCFLO. Then from 2008, I joined the TBK. TBK is a touch panel maker for iPhones. I remember for iPhone 4 and the 4S, we provide 75% touch panel module, including display, to Apple at that moment. Then from 2015 to 2021, I worked in HKC in China. And in these 6 years, I recruit around 200 engineers, and we build 4 fabs. For all of these 4 fabs are G8.6, and it is very economical, cost competitive, and mature process. So we build for this kind of fabs. I think it is also very suitable for India. And after HKC, I go back to Taiwan because of COVID. I want to stay with my family, so I go back to Taiwan. And at these 2 years, I also do some study about AR, VR display, but I just focus on back planes. Yeah, so that's all. Thank you.
Thank you. So the next speaker is going to be, he's sent us a pre-recorded video, and he's the president of Society for Information Display, or SID, where all the display companies are members of. You know, there's an annual event around this whole thing. So Dr. Achin Bhaumik is the president. He's actually from graduate of IIT Kanpur, but he works these days as Chief Technology Officer and Executive VP of Starkey Hearing Technologies. He's CTO and President of Engineering. He's also an adjunct professor at the Stanford University School of Medicine. So he has numerous awards to his credit in this field, and these days he's focusing on micro displays and perception of AR, VR displays. So Dr. Achin, I asked him, tell us what SID is going to do to help India, and this is what he said. Turn it on, please, the video.
To attend Semicon India and contribute to the discussion on semiconductors and displays. So I'd like to start by thanking Dr. Rajeswaran and the organizing committee for giving me this opportunity. And today I'm representing Society for Information Display, the largest organization for display technologies around the world, which I'm going to tell you about. I have the pleasure of serving SID as its president, having been elected in 2022. So a few words about the Society for Information Display. As I mentioned, it is the premier international organization covering the display and imaging industry, which is valued at over $150 billion annually, and by some analysts' opinions, is probably going to double by end of this decade. SID also is heavily participated by the academic community around the world. SID was formed in 1962. In fact, we just celebrated the 60th anniversary for the organization last year. We currently have 6,000 members globally, including from India. SID is known to host the most well-known display technology conferences, such as Display Week, which is our annual conference in the US, IDW, that's held every year in Japan, IMID in Korea, ICDT in China, and Euro Display, that's held in Europe. We also publish prestigious venues such as Journal of SID, Display Week, Symposium Digest, Information Display Magazine, the book series that's co-published with Wiley, as well as the widely accepted and revered display measurement standard, which is used by the industry worldwide. So I'm going to share a picture from the recently held annual Display Week conference in Los Angeles. We had over 5,000 attendees who traveled from around the world to participate in the annual conference of SID. And also, there was a vibrant exhibition. We had nearly 200 companies exhibiting from around the world with their technologies in the displays, as well as semiconductors, sensing technologies, and imaging technologies. So with that, I want to share my viewpoint on the importance of displays in the context of semiconductors. While we're glad to see India step up and undertake this amazing initiative to explore manufacturing for semiconductors, and we strongly believe the same applies to display technologies in terms of opportunities. I'm showing you here a report from Deloitte, and this is a little dated, but in 2021, they estimated that an average US household had 25 connected devices. And when you talk about connected devices, suddenly all of us think about chips, semiconductors. But in truth, most of these devices, if not all, they also had a display panel that goes with it. And the displays, besides forming an important part of the application, they also communicate with the semiconductor chips. And in fact, they also share manufacturing technologies in terms of equipments and processes with the semiconductor industry. I wanted to also show an example of a component cost breakdown. In this case, the data from Counterpoint, talking about the bill of material split in the case of iPhone 14 Pro Max and iPhone 13 Pro Max. As you can see in this gray bar on both sides, the display panel constituted roughly from 19 to 20% of the overall bill of material. The black bar corresponds to processors, semiconductors, and they are about 18 to 20%. So you can see from this example how displays and the chips, they actually occupy about the same importance in terms of the bill of material for state-of-the-art electronic devices. And I want to impress upon you that displays are a hotbed of innovation. Well, when you think about displays, many of us remember the old days of CRTs that used to form the backbone of the display technology. Of course, it changed the way we entertain ourselves around our families decades ago. And as the industry leapfrogged and moved forward, you had tremendous innovations from large size liquid crystal displays, organic light emitting displays, and increasingly, all other technologies from projected screens to micro LEDs forming the essential centerpiece for smartphones, your automotives, robotics, virtual and augmented reality devices, as well as medical applications. So it's safe to say that semiconductors and displays are deeply intertwined, both in their applications and also in manufacturing. I would like to conclude my talk by making an announcement that the Society for Information Display is launching a strategic initiative to establish and grow SID India. And Dr. Rajeswaran is pulling together a team to create this proposal and kick it off. I am proud to say SID is exploring providing the initial funding to help establish this initiative, and we are inviting local sponsors and partners to work closely with us. With that, I'd like to thank you on behalf of the Society for Information Display. I'm sorry I could not be there in person, but if I could continue our discussion, please feel free to reach out to me and this email address that I'm showing you here. I wish you best for the rest of the conference, and I look forward to partnering with India semiconductor infrastructure and organizations in jointly promoting the excitement around display technologies.
So now you can give an applause for the person there. So I just want to say, with respect to this, we will be holding two focused SID-sponsored events. One is coming up in September, where SID with ICEA and another group, organizing group, will do a display manufacturing conference in September. So many of you interested in learning more about display manufacturing in more detail. That'll be in Bangalore, correct, Pankaj? Bangalore, yeah. So, and then in December, SID will work with the premium scientific and technology conference in India, which is IWPSD, in Chennai at IIT Madras, where all the scientists and academic people come together. So business-oriented folks, keep September in mind. And professors and students, come to Chennai, okay? So some of the leading, the inventors of OLED will be there. I'm one of them, but I'm already there. So my colleagues, Professor Ching Tang and others will also be there. And we promise to put on a good special show on OLEDs in both these venues. So SID is going to start that way this year. We have already held 2 manufacturing conferences the last 2 years. So now it's third one. It's getting to be a routine. With that, I want to say that SID, Dr. Achin Bhaumik, is ready to support all of us. And with SID comes all the companies in the SID organization and the supply chain will come to India with lobbying by SID as well. With that, I would like to move to Dr. Ajit Aras from Sharp, and he's going to talk about the business aspects of displays and products.
Oh, great. Okay. And yeah, if you think that looks better than me, that's true. Because display is supposed to show nicer things, right? And besides, I'm a salesman, so that explains.
Yeah,
Unlike most of the intelligent fellow panelists that I have here. Okay, so anyway, my team and me, we work at Sharp, trying to deliver the user interface and user experience, for other brands, right? Because we sell our LCDs to other brands, and then they can create a good user experience with these LCDs. And of course, in my free time, I do some guest lecturing and mentoring to the startups in Singapore. Okay, so yeah, next one, please. Okay, this is for real. This is Sharp and has a long history of innovation, okay, more than 100 years now. But one very notable, somewhere in top middle, if you see, as Dr. Raj mentioned, Sharp was the first one to introduce LCD in a calculator, and that was 1973. Okay, exactly 50 years from today, 50 years ago, yeah? And the LCDs have evolved, as Dr. Raj has explained, and Suraj has explained, and YJ has explained, into various other, better types. Okay, we can go to the next slide, where we talk more about LCD innovation in the last 5 years. Okay, Mr. Bhaumik shared about SID, right? And a lot of activities that happen in SID, and he actually showed, the innovation that SID is helping. And Sharp is a very prominent member of SID, okay? And these are some of the, innovations in displays that are done in the last about 5 to 7 years, okay? And I thought these are more relevant, so we spend a little bit more time here. So Sharp was, of course, the first one to launch the 8K LCD TV, okay? And then, again, no cadmium or cadmium-free nano LED, which will be the next display technology, let's say 2 to 3 years from now. That was first shared in SID, okay? And this was in fact shared in the photograph that Mr. Bhaumik shared in his presentation, right? Okay, and of course, innovation is the way to go, and Sharp has been among the top 3 publication or publishers, okay, in SID within 4 out of last 5 years. Okay, so that's a little bit of an introduction of Sharp. We are, heavily invested in displays. Okay, now exactly as Suraj mentioned, Dr. Raj really gave a very good, explainer of how displays are made and what is the basic structure of displays. And Mr. Suraj then added on top of it and really shared what equipment we use for that and so on. Okay, I'm going to talk a little bit about what happens to the display after it comes out of that fab, yeah, the fabs that YJ built, right? So maybe can we jump 2 slides further, Sudarshanji? Okay, maybe sorry, sorry, can we go back a bit? Sorry. Okay, let's go to that, but before that, one important aspect of Sharp, we have done well in LCDs, yeah, and in business, okay, but this is a company which really focuses on doing good as well, and doing good as much as doing well, right? So this is one of the examples during pandemic, we actually, used some of our, lines, right? because of the air purification lines to actually build masks when there was a shortage. We use some of the technology of low reflection on LCDs to actually make face masks, right? And next slide, please. We can see them deployed by some of the news anchors, and this is in India. Okay, so really not only doing technology just for innovation and advancement and business, but really bringing the technology to use without hesitating, for the good of the society. So that's really a bit of introduction of Sharp, and I think that, is. So yeah, now we can jump 2 slides more, please. Okay, and as I mentioned, so what Dr. Raj explained and what Suraj explained and what YJ explained is typically the step 1 of display. And I took the liberty of consolidating that. It's much more complicated than what it looks here, but then I have my learned fellow panelists who has explained those in details. So this is what comes out of a display fab as a mother glass, right? And then there is, depends on application, for IT applications, you need a slimming process because we want thinner and lighter displays. For televisions, you don't need this. So the step 2 is kind of optional, depends on the application, right? And then the step 3 onwards is again required for all displays till the time they reach our hands as consumers, as products, okay? And these are processed like cell cutting, okay? And then the output of step 3 is a multi-cell, okay? Or a cell, right? And then you need to attach the polarizer and IC bonding, and then it becomes open cell, right? And then you attach the backlight unit, and then it becomes a LCD module, and then of course it goes into a finished product where we use it as a phone or a PC or inside the cars and so on. Okay? And we'd like to discuss this a little bit more as during our panel discussion. So today we talked about the fabs, okay, as one of the major focus of investment, but there are a lot of other activities which can be done right now, which take lesser investments. I would say these are, rather relatively lower hanging fruits that can be, enjoyed by developing this ecosystem here in India. So thank you. Thanks very much for talking.
So now let's thank all the panelists for their slides. Now we'll get into a mode of discussing this. And I was wondering, anybody know what is a fireside chat? How are we supposed to do it? Are you supposed to have a fire? No? Organizers, no fire? Okay. So let me kick off this. You remember my slides, right? I had 4 slides that I want you to look at. The first one was the industry is growing, $150 billion. Our president at SID is saying he's hearing from analysts it'll go to double. Where is this growth going to come from? How do you create $150 billion more business in 10 years, let's say? Suraj?
So one thing I visualize, the entire conference, the wall, will be covered with display, right? This is an area-dependent industry. How do you make it foldable, flexible? I think increase the area. That would be the way to go.
Of course, as you are seeing now, I think mobile phones drastically changed, right? And we said we are carrying computers in our pocket, right? And the same thing is happening to our cars as we speak, okay? So there is, the computation in cars is increasing exponentially today. Business models are being developed around, having the computation power. And of course, communication is improving on speed. I mean, you have 5G and so on. And then how does all this information interact with the user of the car? The user of the car may not be driver of the car any longer, right? So in the 30 minutes or 1 hour or 2 hours that you are taking a ride, what do? Have nice displays there to enjoy that ride. And of course, I'm creating a little bit of a exaggerated picture. But today, as you see in cars, that is becoming one of the big market as we speak. And I think I will refer to one recent article after the last auto show in Delhi, and that described how LCDs are becoming one of the key differentiators for automotive vehicles now. So yeah, that is one of the zones to look at, besides other zones, of course.
Yeah, I think we will need a more larger and larger television. Yeah, so if economy is still going up in India, yeah, so everybody, not everybody, most of the people want to, if they can buy, yeah, they want to buy larger and larger television. Yeah, larger and larger television will consume capacity very efficiency and very large because the area is really large. Yeah, so I think this is also a very good point, good market in the future. Yeah.
So that's good. The audience, I have a question for you guys. How do you like driverless cars in India? Would you get into a driverless car? How many of you would get into a driverless car in India? Because you can do other work in there. You put displays everywhere inside the car.
One person said yes.
He said yes. Yeah. Very brave man. Yeah, so it can grow that way. You can put displays in the car. You can get into your car, go to your work, shopping, watch displays. Nobody's driving the car. Sounds good? But anyway, the industry is going to grow. That's a feeling from all the experts who have been in this business. But it requires fabs. India has an opportunity here to first mover, new product segments, and then you can compete. You never go in and compete at cost just because today the price is cheap coming from some other fab. You have to always look for a higher added value margin. I didn't tell you that the two display technologies, LCD and OLED that I described, they require different types of backplanes. So the cost of making the backplanes, the capacity of the backplanes, the number of mask levels increase, you have less capacity, it means you need to put in more investment upfront. So that's why there is a difference in price of LCD and OLED, even if the yield were exactly the same. Now, in the future, this is not going to be the same because new technologies are coming and they'll reduce the cost. LCDs and OLEDs have been added for now almost 22 years of, and each has, even though they have grabbed market share from one another, the whole pie has grown. The market has grown. That's what will happen in the next 10 years, I believe. So the other point, you know, that maybe you can comment on the equipment point of view, do you think they'll be even larger than 10.5 equipment, or is it going to go smaller because the applications are getting smaller?
Yeah, I think you had segmented, right? There is a TV segment that grows, and if there is any other large area application, then definitely scaling with size matters. But if the growth is going to come from the smartphone, wearable, and that kind of the application, then maybe going with a different kind of approach might make better sense. So some of it depends on where growth is going to come from, right? Things like AR, VR, we don't know. Maybe if they take off, it depends on where the market drivers are going to come from. Large area-driven application, generally scaling has always worked.
I think just like a semiconductor, 12-inch maybe exists over 15 years. Everybody discussing about 16-inch, but nobody really to do that. So I think for the equipment point of view, if we continue to enlarge the glass substrate, maybe they will make a lot of risk, not only glass maker, also TFT maker. Yeah, so I think G8.6 to G10, maybe most of the economic, yeah, for every kind of application, yeah. Yeah, but for example, for low temperatures, maybe we can have car over G8.6, something like this kind of a thing, and make is possible, yeah, for larger glass substrate, yeah.
I think YJ really hit on the nail. So I think it's not just the bigger is better syndrome, but rather what is the NUPS, as you mentioned, the cut efficiency, you know, and for from an application point of view, there is always a certain size that is the best. Even if you go bigger than that, it doesn't really help because, you know, we need to, from a factory perspective, you need to input a certain number of mother glasses for the factory to have its return on investment point of view. And then multiply that with the N-ups, as you mentioned. If we do some smaller sizes, for example, this N can get into like about 30 or 40 at times, or even more than 100, depends on what size we are doing. So it all needs to be tied back to the demand calculation to get the right optimal economy of scale, absolutely, yeah.
Thank you. I'm going to ask you the next question. This is related to customers. Fabs can be built. We have built fabs. He's built a lot of fabs. I've built fabs. The point is, who's going to buy all these things? And what is the role of the customer in this process? Since you are looking at devices from Sharp, how does the process work differently from semiconductors in the spec process and the development of product and the yield, all that kind of stuff? Can you comment on that?
No, thank you. You asked me that. And, in displays, one of the common display that we all have with us is our phone, right? And on one side, you see more and more appliances or applications using display now, okay? Because displays are available. A lot of innovation has happened on the display in terms of power and in terms of price. Power consumption and price both, efficiency certainly. Okay, but at the same time, there are a lot of applications going non-display, some things like e-chargers and things like this, because you can actually settle most of the things on the phone, right? So the point is, what is the key value that we are going to add by this display, okay? And what is that value to the customer? So when let's say in a PC application, for example, definitely, productivity is one of the key factor of a PC. Okay, and then most customers are looking after the power consumption there. So we and most of the LCD makers or even OLED makers are spending a lot of resources and money on innovating, on the power improvements of the displays, right? So we're working on like 1-watt panels. We are trying to drive panels at a lower frequency so that you can save power on the display, as well as the CPU is not so strained, so that the whole system power is reduced. So, for example, that's one of the applications. On other side, because we are having more and more CPU power that is being developed, which is coming directly from semiconductor, there is a lot of information that can be processed, right? Add to that the communication speeds which are increasing, right? And therefore, the resolution of display is now expected to be more and more because we need to show that much information in the available space. Okay, so these are like 2 examples to go where, how customers, or I would say the demand decides what are the innovations that are, invested in or appreciated.
Okay, I would say that the end customer is very important. They decide the spec and then provide it to the maker, the display maker. The fabs can only operate the best they can under the design rules that they've invested in. So the yield and the discussion of the yield versus is a compromise. There's no standards here in the display industry. Every product means a different spec. That means the fab must operate with multiple different products with different specs from the customer expectations and keep the yield high so they can make some money. I would like to talk more about this, but I had a note saying they're all getting hungry for food or something like that. So I think we should wrap it up.
Sure.
Huh? You all look very tired, so maybe it's time for a refreshment. So I want to summarize what we heard today. Well, one thing, economies of scale. Keep that in mind. So far, it's been driven by economies of scale. Larger the product, larger the fab. This may change over time because the applications are going smaller and mobile. Some people want product format that are flexible, rollable, foldable, all that, which cannot be done with LCD technology, but can be done with OLED technology. So preferences for what kind of products you need depend on what is the product you want to drive. So customer has a sway. India, as you move forward on the first fab experience, you should make enough added value to build a new fab without the government assistance. That is important for sustained business. Please do a lot of R&D. I had one slide to explain before, but I want to terminate this. R&D is very, very important. This is a technology-driven business. Every 5 years, technology changes. So anybody investing must also invest in R&D and keep relevant for new generation of products and for differentiation and product portfolio, IP patent portfolio development. With that, did I summarize what we just discussed? So please remember that we are sometimes like semiconductors, sometimes semiconductor plus, but mostly we're using a lot of learned experience in semiconductors into display manufacturing, especially the TFT backplanes. With that, maybe we are finally done. Now you can give us a round of applause, please. Thank you.
Thank you very much.
Thank you.
Thank you so much, moderator. And